And we also did the definition of waves, right? Wave transfers energy and energy is expressed as the wave move. You wrote, right?
Yes, sir.
What you wrote, can you say the 2 points?
Waves, waves transfer energy and energy spread as the waves move. Waves transfer energy without transferring matter molecule.
Okay, so you can remember this, right? That waves transferring, you can remember this example I gave you, right? From the middle, the wave is transferring, the particles are not moving. This cap is the proof, right? Now we have the waves in ropes, springs, and water. Spring, you see, this spring is stressed, right? Hello?
Yes, sir.
So this process is happening by forward and backward movement. Once you are stretching the spring, then you are pushing the spring that way. Is it clear?
Yes, sir.
So this way we are getting the compression wave and direction of propagation. When it is compressed, the direction of propagation is right side. Is it clear? Hello?
Yes, sir.
The energy transfer. They are saying propagation of energy. Direction of energy transfer is right side. Again, we have the rope. Rope, we are making waves ups and down, right? We are making the waves ups and down, so we are having the shear wave. Shear wave means you are using your hand to move the rope up and down, right? And the direction of propagation of your wave is right side. That is energy transfer. Is it clear?
Yes, sir.
So this is man-made wave. We are having two waves produced here by spring and rope, and we have some natural waves like water waves, right?
Yes, sir.
You see from the tree, the drop of water is falling on the pond or the place or the river. So the wave produced, right? And it's going like circular wavefront. It's going like circular, huh? And it's moving and getting bigger and bigger and bigger, right? The transfer of energy. This way it's transferring the energy. Then we have wavefront. Okay, wavefront is the you see here we have two kinds of waves. Both are water waves, but one is circular one and another one is parallel waves. You see here there are straight lines waves and the particles are moving up and down. That one is shown by these lines. And here we are having the spherical dipper, and from there we are getting the circular wavefront. So is it clear? Yes. Switch on the fan. So these are the first one is called plane wavefront. Huh? You have the first
What they
diagram.
call
We have plane wavefront.
wavefront. Yes,
Yes.
sir.
And why we are saying wavefront? Because wave is the product of wavefront. Okay. So what is called wavefront? A surface containing
A surface
points.
containing points affected in the same way by a wave at a given time.
Okay, surface containing points affected in the same way by a wave at a given time. So, in the same time, this surface containing lots of points, right?
Yes, sir.
And all these points are affected in the same way. So, the combination or the collection of all these points, uh, they are called wavefront. The same way we have the circular wavefronts, right? And we can also define wavefront in the second definition. Can you read this also?
An imaginary surface joining all points in space that are reached at the same instant by a wave propagating through a medium.
So you can write any of the definition. Which one you prefer? Which one you prefer? The first one or second one? Huh? For the definition of wavefront, which one you prefer? The first one or second one?
The first one.
First one. Okay, so you memorize this. Huh? Can you read again the first one?
Surface containing points affected in the same way by a wave at a given time.
Now we will try to understand some of the terms related to waves. First of all, wavelength. We can represent a wave this way, right? This way we can represent one wave, and we see the upper side of the wave and the lower side of the wave that's going a bit, sharp, right?
Yes, sir.
So the upper side of the wave is called crest and lower side called trough. Is it clear? So here in this wave we have two crests and three troughs. Is it clear? Hello? In this wave we have two crests and three troughs. Do you understand it? Look, this one is one trough. The first one is one trough and another one is this trough. So is it clear that there are three troughs and two crests? Farabi?
Yes, sir.
So what is called crest? The upper peak point is called crest, right?
Oh, the upper peak point is called crest.
And the lower peak point is called trough.
Trough.
Is it clear?
Yes, sir.
Now we have the definition of wave. We have the definition of wave. Huh? Can you read the definition of wave?
Sir, wavelength, the distance from crest to trough.
Wavelength, wavelength.
So the distance from crest to crest or trough to trough is called wavelength. Or the distance traveled by a wave horizontally in the direction of propagation for a complete cycle. Complete cycle consists of crest and the trough or a compression or a rarefaction.
So look, in this way, here the wave starts here, right?
That's right.
And this is half of the wave. You know, the compression or rarefaction, I'm showing you. Just give me a minute, I'm showing you, no problem. Here. In water, the wave is going like this, right? Hello. Arabi, can you see?
Yes, sir.
So when the particle is moving up, we are getting crest. And when the particle is moving down, then we are getting trough. Okay. Particle is in its place here. It's not moving from its place, but we are showing it separately so that we can understand it better. Is it clear? Hello.
Yes, sir.
So when the particle is moving up, we are getting crest, and when the particle is moving down, we are getting trough. Now, for one upside vibration and one downside vibration, we are getting a complete vibration, right? One upper vibration and one lower vibration of the particle is giving you a complete wave, or we can say it is complete cycle. Is it clear?
Yes, sir.
Hello? Is it clear?
Yes.
And this is one kind of vibrations. This is for transverse waves. The when the particles are vibrating up and down, then we are saying it transverse waves. Like water wave is one kind of transverse wave. But sound wave is moving in the air by compression and rarefaction of the compression or expansion of the air molecules, right? This way, you see, So here we are getting expansion and here we are getting compression of the air molecules. Is it clear? Hello, Farabi.
Yes, sir.
Air
Yes.
air column is expanded here and air column is compressed here. So by this compression and rarefaction, this expansion is also known as rarefaction. You see here it's written rarefaction. Rarefaction means what? Expansion. Expansion. Okay. Rarefaction means expansion. So in our wave, the compression the compression we are getting, that is represented by crest, and the rarefaction we are getting, that one rarefaction or expansion, that one is shown by trough. Is it clear?
Yes, sir.
Hello.
Yes, sir.
So one compression and one expansion is making a complete wave. So this one is compression, this one is rarefaction. In longitudinal wave, that is sound wave, we are getting compression and then we are getting expansion, right? The particles are moving left and right. The particles are moving how?
Left and right.
Left and right, forward and backward. That's why they are called longitudinal wave. The wave is going right side and the particle vibration is parallel to it. Okay. With the direction of energy transfer, the particle vibration is parallel. That's why it's called longitudinal wave. And water wave, this is sound wave. Sound. And this is water wave. So you please draw this. Whatever I am drawing, you should draw it. So particles movement is here up and down. And here particles movement is forward and backward. We are getting here compression and rarefaction. Compression is similar to crest and rarefaction is similar to trough. Rarefaction means expansion of air columns. Farabi, are you writing now?
Yes, sir.
Farabi, on
Yes,
your
sir.
physics copy, note copy, you wrote some of the things on Thursday, right?
Yes, sir.
So you wrote the date, Thursday date, 3rd of September, right?
Yes, sir.
3/5/2020. Now you are writing something today, you should write today's date. Arabi, finish writing.
Yes, sir.
Hmm.
Hello?
Yes,
Sir, finish writing.
very good. So now look, the distance from the crest to another crest, one crest to the another crest, that distance is called wavelength. Or the distance from trough to next trough, it is also called wavelength. Then we are starting the wave here and we are ending the wave here. So this trough and one crest, making one complete wave. Is it clear? Hello? This is lambda wavelength. Then this is also lambda wavelength. So wavelength can be defined in three ways. Parabi,
Yes, sir.
wavelength can be defined how many ways? Hello?
Yes, sir. Hello?
Yes, wavelength can be defined in how many ways? Three ways, right?
Few ways. Yes. Yes.
Yeah,
Trough.
crest to crest distance, trough to trough distance, and starting of the wave to the end of the complete wave, right? We know that one crest and one trough is a complete wave. Similarly, we can say one trough and one crest is a complete wave. Is it clear? Hello, Parabi, is it clear? Parabi,
Yes, sir.
okay. Now what you will do, you will take the notes, summarize. The first one you will write wavefront. This one, the first definition of wavefront you write. Can you write?
Yes, sir. So first we'll write the definition of wavefront.
Yes. The first definition is done, right? Now you write the heading wavelength.
Sir, can you go to please wavefront?
Here.
Yeah. So now you can go to wavelength. Hello, sir.
Yes. Wavelength definition. You write later. First you draw this diagram.
This one. Place
This one,
reference.
this diagram. Yes. From here you draw so that you are getting 2 crests and 3 troughs. The way it's given in the notes. Then you label crest, trough, and get the distance between 2 crests, 2 troughs. Label them this way. This distance is wavelength lambda. Crest to crest, this is wavelength. And from starting of the wave to the end of the wave, this is also wavelength, that is lambda. Lambda is the same symbol of wavelength.
Sir, I level it. Draw and level the diagram. Yes, sir. Hello.
Yes, yes.
Sir, I have drawn it.
Yes, drawing is done.
Yes, sir.
Okay, if your drawing is done, the way I told you, that way you are done, right? Now you write this definition. Both the definition you write.
Wavelength.
Yeah, wavelength. ভালোই লাগতেছে।
Sir, I have written it.
Finished wavelength, both the definitions.
Yes, sir.
And you also write that wavelength is represented by Greek letter
Yes, sir, I have
lambda
written it.
and SI unit is meter.
Yes, sir, I have written it also. I wrote it also.
Very good. Look, in this diagram we showed all. It is from crest to crest, then trough to trough, then starting of the wave to the end of the wave. All together we showed everything in this diagram. Do you understand? Then amplitude. What is called amplitude we are now going to understand. First you understand, then you write, okay? Look, in this diagram we are showing amplitude. This is the particle's rest position. Okay, this line. Can you see this line? This is particle's rest position. That means if there is no wave, the particle is staying in place, in this place. Now, there are thousands and millions of particles, water particles, right? Hello. So, when the particles are vibrating, there is not only one particle is vibrating, all these particles are vibrating. For example, the particle here is vibrating this much, and particle is staying here, that particle is vibrating this much, water particle, okay? And here we have another water particle, this particle is vibrating this much. So this way we have lots of particles vibration. It's not only vibrating upwards, it's also vibrating downwards, this way. This particle is vibrating downwards and we are getting this one, the middle one. So from the rest position, the particle is vibrating and moving upwards and then moving downwards. So it is changing its place, right? Hello. It is displaced from its place, isn't it? Hello, Paravi. The particle is displaced from its place upwards and downwards, right? Hello, Paravi. So this displacement, when the displacement is maximum, you see we have displacement here, we have also here displacement. Now which one is maximum displacement? Paravi, which one is maximum displacement? The middle one, right? So the displacement which one is maximum, that one is called amplitude. As the particle is vibrating both upwards and downwards, and it is the rest position. Rest position is also here. So we are getting two amplitudes. How many amplitudes? Two amplitudes for a complete wave. One amplitude we are getting for crest, another amplitude we are getting from trough. Is it clear? Paravi, what is called amplitude?
The maximum displacement of vibrating particles from their rest position is called amplitude.
Yeah. Then continue.
There are two amplitudes in a complete wave or cycle.
Yes, so we are having two amplitudes. One is upper amplitude and another one is lower amplitude in a complete wave. Is it clear? Now you write. You draw this diagram and label amplitude in this diagram. And it is your rest position. You give a line in the middle. It is your rest position. From the middle line, you label amplitude this way, and here also label amplitude. Can you do it now quickly? Hello, Farabi. Yes, Farabi. Farabi,
Yes, sir. Sir, are you hearing now?
are you done with amplitude?
Yes, sir.
So frequency now, huh? We will discuss now frequency. You see, frequency is written here. First, we are making you understand what is called frequency. Then you will do it. Okay. Look, we have here uh, waves, right? Look, how many complete waves are available here? From here to here, one complete wave, right? One cycle, then two cycle, then three cycle, right? Hello.
Yes, sir.
So for this, all these three cycles to complete, after this we are not considering whatever. There is also some extended part, half of the wave, that is we are not considering. We are considering that these three complete waves or three complete cycles, uh, they they require 1 second. How many seconds? 1 second to travel this path. Okay. To For all these three complete cycles, we need 1 second. So the frequency of this wave is 3 hertz. How we got this? From this definition. The number of complete waves or cycles per unit time or per second is called frequency. So you first give the heading frequency, then you draw this diagram. Only you draw this wave. You draw this wave in a way that there is three complete cycles, not this part. Till here you draw. Only the red color part you draw, the way they did. And you give this arrow. This 1 second only you give. Okay. Is it clear?
Yes, sir.
And then you label this one as frequency 3 hertz. After you are done with drawing, you write this, the definition and the symbol of frequency, then unit of frequency, SI unit of frequency. Just write all this. Once you are done with this, then our class will be over today.
Sir,
Yes.
next writing.
You finished writing frequency? Hello?
Yes, sir.
Very good. So what you did today? We did today wavefront, right?
Okay.
Then after wavefront, we did wavelength. Then we did crest, trough, compression, rarefaction, right?
Yes, sir.
And we did also amplitude, isn't it?
Yes, sir.
After wavelength, we did amplitude. Then we did frequency, right?
Yes, sir.
So please revise this all. Huh? At home, you try to revise all this. We will discuss all these things later on again. Okay, inshallah. Okay, Allah Hafiz, huh? Today.
Yes, sir.